Okay, this goes along with 5-12. This is the applications of two variable inequalities. First off, it says, suppose you intend to spend no more than $60. On your paper, circle $60. I mean, not $60, more than. No more than. I would circle no more than and put less than or equal to. That will help me remember that that's the symbol I'm supposed to use. Hardback cost $12 and paperback costs $6. Let X equal the number of hardback books and Y equal the number of paperback books. Write an inequality to represent the number of hardback books and the number of paperback books that you and your friend can buy. First off, it says hardback are $12. Well, this is the hardback, that's $12, and Y is the paperback, which is 6. So I have 12X plus 6Y, no more than, less than, or equal to 60. We should be able to write that inequality. It says to graph it. Well, we need to solve for Y. We need to put it in slope-intercept form. So if I go through and do that, I'm going to subtract 12X from each side. I get 6Y less than or equal to negative 12X plus 60. Divide by 6. I have Y not equals, whoopsie. Y is less than or equal to negative 2X plus 10. Okay, so now right here on my graph, X is the number of hardback, right? No. Yes. X is the number of hardback. So I'm going to put hardback books. And Y is the paperback. Well, so to start by graphing, it's at the y-intercept is at 10, so I'll go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and put a dot. Now let's graph my line. The slope is negative 2, so I go down 2 and over 1 and put a dot. Down 2 and over 1 and put a dot. Down 2 over 1, put a dot. Down 2 to the right 1. Down 2 to the right 1. Now it says less than or equal to. So that means that it's equal to. So I have a solid line, and I'm going to connect my dots. Now before you do anything else, it says less than. So let me do something and don't do anything on your paper. Less than means below the line. That would mean everything here in this highlighted area, right? But here's my thing. What is X and Y? What are we talking about? Books. Is it really everything in that shaded area? Why not? You can't have half of a book. So actually, my data is supposed to be discrete, right? Meaning that it's dots. Well, if that's true, what type of solutions can I have? You could have 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0. I can go up here and I can have all of these whole numbers right here. Like this point that I just colored in is 1, 1. I could have one paperback, one hardback in my budget. So everything right here that I'm going in, all these whole numbers, I'm putting dots on. Those are my actual solutions to this problem, because those are the only things that can work for how many books you're going to buy. Now, would you really like to go through and put dots on every whole number like this? Or is it easier to shade? It's easier to shade, and then we just have to know what can be our solutions. So if I had asked, let me finish putting my dots just because I can. All right. So actually what's in the blue is all the solutions. But we shade below that line because it's just easier to see that it's below. We need to look for data that's below the line. But see, if I had something that said 0.5 and 1, is that a real solution? No, because you can't. This is the X, this is the Y. You can't have half of a hardback book. Okay, so this is not a solution. So it says right here, what does the coordinate 2, 9 mean in relationship to the situation? 2 is the X, Y is 9. Well, this is X, hardback book, so it would mean 2 hardback books and 9 paperback. That's what it means. Is that a solution? 2, 9. I go over 1, 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Up here. Is this dot right here, 2, 9, is that a solution? No, it is not in the shaded area. If you bought two hardback and 9 paperback, it would cost more than $60, and that's not in our budget. So it says, is this coordinate appropriate for the situation? No. Why? Because it is not in the shaded area. Is the 0.5 and 7.5 a solution? No. Now the 7.5 is the Y. The Y is the paperback. Because you can't have half of a book. What would be some solutions if we came up here? Give me some solutions that are up here in this shaded area. Let's see, I heard a 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. That would be up above it. Well, maybe it is. 1, 2, 3. No. 3. So what about 2? 1, 2, 3, 4, 5. 2, 5 would be. 2, 5 would work. How about 0, 1? 1, 2, 2, 0. Any of these in the blue that I put dots on are solutions. Next one. Suppose you are responsible for recycling metal cans and plastic bottles at your school. How many bags of each type can you send to the recycle center? Wow, I can really read today. If the trucks hold no more than, all right, right there, circle no more than. What is that symbol? Less than or equal to. All of these are the same equations. All you need to look for is this symbol. Where is the less than or equal to? Somebody said C. Who said C? B, right here, less than or equal to. Okay. Next one. Take a minute and try and do number 3, please. Right now, try and do number 3. Okay, on number 3, it gives us the inequality 3x plus 2y is greater than or equal to 60. The easiest way to do this problem is to substitute the x and the y in there for those numbers and see if it equals greater than 60. So I have 3 times x, 3 times 11 plus 2 times 12, 33 plus 24, that's 57. That's not greater than. So it's not A. I have 3 times 12 plus 2 times 14, which is 36, plus 28, which is 54, right? No. What is that? 64, right? That one works. Huh? Oh, well, you just need to be patient. 3 times 14 plus 2 times 8. What is 3 times 14? 42 plus 16, which is 58. That doesn't work. Then I have 3 times 10 plus 2 times 14, which is 30, plus 28, which is 58 again. So the only answer we have is B. Number 4. Alan is planning a birthday party. He can spend at most. What is at most? Less than or equal to $10. He wants to buy packages of plates and napkins. So all we need, the only information we need are the plates and the napkins. It says write any inequality represent P the number of plates, and N the number of napkins. So I've got $3 times P plus $2.50 times N is less than or equal to $10. So now you just need to go down here and we need to multiply the numbers and see which ones give us less than $10. So the first one's here. I've got $3 times the plates, which is 2. Let's try that again. $3 times 2 plus $2.50 times the napkins, which is 1. Well, 3 times 2 is 6. 6 plus $2.50 is $8.50. That one works. The next one, 3 times 3 packages plus $2.50 times 1 package. Well, that's 9 plus $2.50. That's $11.50. That's too much. 3 times 1 package of plates plus $2.50 times 4. Well, that's 3 plus 10, which is 13. That doesn't work. Next one, 3 times 1 plus $2.50 times 2. Well, that's 3 plus 5, which is 8. I've got 3 times 2 packages plus $2.50 times 2 packages, which is 6 plus 5, which is 11. So these are the only 2 options that would work on these. I thought there was another part to that. Was there not another part on your paper? Okay. Next right here. It says using the graph to the right, answer the following questions. We need to write a domain. Now, is domain X or Y? Domain is X. Okay. So over here on my X, I've got, well, let's see if I can do it this way. Let me try and box off. My X starts right here, and what number is this at? This starts right here at -3, and it goes all the way, the X goes all the way over to what number over here? Okay, comes all the way over here to 1, 2, 3, 4. Every number, every X number between -3 and 4 is the domain. Okay, we're not talking about up and down. We're talking about from left to right. So how you're going to write this is you're going to put -3. You're going to have X's in between -3 and 4. Remember, from the beginning of our unit, our symbols went this way. Now, I put the line underneath of it for equal to because it's a colored in dot. If it's not a colored in dot, if it has an open circle on it, you would just leave it with the symbol of less than. All right, solve the inequality below for y. And it's equivalent to, and so you're supposed to fill in the blanks. First off, I have, it doesn't matter if you move the 12 or the x first. It doesn't matter. I'm going to go ahead and move the 12. And then I have 3x minus 6y greater than or equal to 12. I'll subtract 3x from each side. Negative 6y greater than or equal to negative 3x plus 12. Now I'm going to divide by negative 6. Ding, 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 ding. What do you have to do when you divide by a negative? Flip the sign so it becomes less than or equal to. Right here I have y less than or equal to negative 3 divided by negative 6 is positive 1/2 x. Well, that's what they have right here. And then 12 minus 6 is negative 2. So to fill in up here, I've got less than or equal to, and then minus 2. Take a minute and try and do the next one. Okay, so again, it doesn't have the blanks on this one, but we still just, when it says equivalent, what is it the same as? I'm going to move the 8 over first, so I'll add 8 to each side. I get 4x minus 2y less than or equal to 8. I'm going to subtract 4x from each side. Negative 2y less than or equal to negative 4x plus 8. Divide by negative 2. Ding, 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 ding. Make sure you flip the sign so it becomes greater than or equal to. So y is greater than or equal to 2x minus 4. Number 8. Okay. Here it says you and your best friend decide to buy CDs and DVDs. And it says that the CDs cost $12, the DVDs cost $18. Between the two of you, you're able to scrape together $180 to purchase the videos and DVDs and CDs. Okay, so it gives you the inequality, and it tells you that X is the number of CDs and Y is the number of DVDs. All it says is if you buy 7 CDs, what is the maximum number of DVDs you can buy? Okay, 7 CDs. The CDs are the X's. So let's go over here to where it's 7. Here's 7 right here. Now what you're going to do is you're going to go up to the first whole number, or the highest whole number that you can get to find out how many DVDs you can buy. So I go here and I'm going to draw my line back over. Well, what is that? 1, 2, 3, 4, 5. So that means I can buy 5 DVDs. So all you do is go over on the graph to where it says 7 CD. You're going to go up to where your line is. And it's because it's where your line is because it's equal to. And then you'll go over and figure out. So the combination you can buy is 7 CDs and 5 DVDs. Well, if you think about it, you have $12 times the CDs, which is, how many CDs did we get? 7 plus $18 for 5 DVDs. And when you put that together, it should be less than or equal to 180. Then it says, if you buy 3 DVDs, what is the maximum number of CDs? So if I go back over here and go to 3 DVDs, 1, 2, 3. There's 3 DVDs. Let's go over to the line. First whole number I find, or the whole number that's closest to the line is right here, and I go down. What number is that? That is 10. So it would be 10 CDs. Here's the next one, number 9. Take a minute and try and do number 9. Okay, so it says to graph the line, y is less than or equal to 3x minus 4. So we're going to come over here and we're going to go down to -4. 1, 2, 3, 4. Put a dot. The slope is 3, which is 3 over 1. I'm going to go up 3 to the right 1. Up 1, 2, 3 to the right 1, put a dot. Up 3, 1, 2, 3 to the right 1 and put a dot. Up 1, 2, 3 to the right 1, put a dot. Or you can go backwards and go down 3 to the left 1. Down 3 to the left 1. It says an equal to, so I will draw a solid line to connect the dots. And now I need to figure out where to shade. It is less than. So I'm going to shade down here, because if I went to the y-intercept and drew a line down, this is the side. So everything in this shaded area is a solution. Now it says to circle all the points that are in the solution set. So if they are in the solution set, they're in the shaded area, or because it's equal to and it's a solid line, it is on the line. So let's see, I'm going to circle this one. Wasn't there another one right here? Yeah, that one right there. Circle. Put an X on the ones that are not in the solution set. Number 10. Write an inequality write the inequality on the line provided for the graph shown. First off, I'm going to go, it doesn't matter how you do it in different ways. I know it's going to start Y, so I'll start off with that. Well, this is a dashed line, right? And is the shading above or below? So if I go to the y-intercept, is it below? Is it down here? No. Is it above? Yes, it's above, so it's greater than. So now I have that symbol. Now I need to just find my slope and my y-intercept. Y-intercept always is the easiest. 1, 2, 3, 4. Well, maybe. I'm looking at 5, I think. It's 4? It's 5. Okay. So I have 0, 5. Now my slope, down 1 and over 1. Too far. Down 2 and over 1. Too far. Down 3 and over 1. Let's test it. 1, 2, 3 and over 1. Yes. Down 1, 2, 3 and over 1. -3 over 1, which is -3. So it'll be -3x plus 5. Next, right here, take a minute and try and figure out which ones are true and which one is false. You also need to, I think you may use the graph if you want. I am going to graph it, so I would suggest you go ahead and graph this one. Okay, on this one, it says Brandy is graphing the inequality y is greater than or equal to 3x minus 2. She graphs the line y equals 3x minus 2 and then must decide on which side to shade. She tests the point 0, 0 and finds that it makes the inequality true. How should she graph her graph? How should she shade her graph? Okay, when they talk about test points, because see, when I'm telling you to shade, I'm telling you to, if it's less than, to go to the y-intercept and go down. If it's a greater than, to shade it up. What they're talking about is if I plot the point -2, let's start with the y-intercept and do the slope. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay, and since it is equal to, it's a solid line. So I'll connect my dots. Okay, so what it's saying is that they used 0, 0 as a test point. A test point means they plugged it in here. 0 greater than or equal to 3 times 0 minus 2. That's what they're talking about, test point. They're plugging it into this, and they're getting 0 is greater than or equal to -2. Is that true? Is 0 greater than or equal to -2? Yes, this is true. If something is true, it's a solution. And if it's a solution, it's in the what? shaded area. That means that the side with 0, 0 right here is in the shaded area. That's one of the ways that you can figure out which side to shade. You can pick a point, substitute it into the inequality, and if it makes it true, like up here, then that's the side you shade. So over here it says she does not need to shade her graph. That is false. I had quite a few people on the quiz. They put the line, but they didn't shade one side or another, and that means it's wrong. Inequalities have to have shading. It said she will shade the side that contains 0, 0. That is true. She will shade the side of the line that does not contain 0, 0. That's false. She needs more information before deciding. That is false. Okay, number 12. Determine whether each of the following statements are true or false. The origin is a solution to the inequality. What is the origin? 0, 0. Here it is. Is it a solution? Yes, it's in the shaded area, so it is true. The point 2, 1 is included in the solution set. Over 2 and up 1. What about this one? Yes, it is true. -1, 9. Over -1, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, I can't write right. Or see, 1, 2, 3, 4, 5, 6, 8. There it is, right there. That is false. It is not in the shaded area. All the points on the line, on this line right here, are not included in the solution set. This is a dashed line, right? So it is not included. So this is true. What does this line have to be in order for it to be a solution? A solid line. It says all the points on the line are included in the solution set. This is false. Okay, is that the last one on that paper? There's one more. There's a secret one. Just kidding. I have to scroll down. Oh, there's one more. There we go. There are infinite points that would make this inequality true. What is that saying? This is just saying there are infinite points that would make this inequality true. Are there a lot of points? There's a lot. It's everything in the shaded area. So this is true.